Good morning, my name is Käthe Goossen. I would like to greet you all from Cologne and present to you our results on strategies for effective study author contact to leverage existing research data when preparing systematic reviews. This was a randomized study within a review, also called a SWAR. The study was performed within a systematic review of the hospital volume outcome relationship in total knee arthroplasty, and this review received public funding by the German Federal Ministry of Education and Research. All authors declare that they have no conflicts of interest related to this work. As we all know, primary study data reported in peer-reviewed publications are the foundation of systematic reviews. However, in practice, reporting is often incomplete. Amongst others, what seems important to report in a publication differs depending on the research aims and context. Also, reporting guidelines have often not been available for all included studies at the time of their publication, and they are used with varying degrees of adherence. Most journals have a word limit, and older publications do not necessarily have full supplemental materials online. For this reason, reviewers are regularly faced with study data that have been collected but not reported. These may be leveraged by contacting study authors for additional information, and author contact may thereby help to reduce research waste. Author contact is quite a common step in Cochrane reviews, performed in nearly 3 out of 4 such reviews in 2016. For other types of review, this number may well be lower. Reported author contact has been found to correlate with systematic review credibility as measured by Amstar scores. From published evidence, we know that author contact is valuable to identify unique data. For example, Mersinger Reynders have shown that author information affects risk of bias assessment, grade scores, and outcomes. Previous comparative research has focused on response rates. These are often higher when authors are contacted by email compared to letters, when their work-based email account is used, and when questions are personalized. In addition, multiple contacts using the same method are less effective than using a combination of methods, meaning letters followed up by email or email followed up by telephone. The final 2 points in this box are not modifiable by the reviewer. Questions relating to clarification of methods are more often replied to than requests for missing data, and authors of more recent studies are more likely to reply than authors of studies published a long time ago. In contrast, response rates were not affected by the eminence of the email signatory, use of a multi-stage contact strategy consisting of pre-notification, request for missing information, and active follow-up, by the number of items requested, or by the use of more than 2 or 3 contacts made to the same author by the same means. In terms of non-modifiable risk factors, US authors were not more or less likely to reply than authors from other countries. Building on the available evidence I have just described, we aimed to find out whether there was a difference when contacting authors in the email main text or sending out self-developed standardized data request forms as attachments, which is a tool suggested in the Cochrane Handbook. Our hypothesis was that study authors might perceive the workload to be lower when asked questions in the main text of an email than when receiving data collection forms as email attachments. A lower perceived workload might in turn elicit a higher response rate. Conversely, standardized data collection forms might give a more complete response than free text in emails because items might be overlooked more easily in an email. With our ongoing systematic review of the hospital volume outcome relationship in total knee arthroplasty, we had a suitable review to embed this methodological research because the final set of included studies consisted of 78 publications with 57 unique corresponding authors, which is a lot more than the published mean of around 14 studies per systematic review. In addition, the nice work done at the Northern Ireland Hub for Trials Methodology Research in building up suitable repositories for studies within trials and reviews inspired us to want to contribute to their efforts. So before starting our research, we drafted a protocol and registered it in the SWAR repository. We designed a randomized study with computerized one-to-one allocation. The reviewer responsible for contacting authors and managing data was blinded to the allocation sequence, and the study authors were blinded to the conduct of the SWAR. As participants, we included all authors of studies that were eligible for inclusion in our systematic review and conducted by unique teams of investigators. We avoided contacting the same authors separately about different studies. There were 2 intervention groups. The email group received all queries in the email main text, and I will show you a sample email in a minute. For the attachment group, we developed standardized data request forms. We partially pre-filled these with whatever information was available and highlighted fields that needed author input. To contact authors, we started by identifying a valid and up-to-date email address, either from the study publication itself or by screening other publications in PubMed, searching institutional websites, Googling, or even by analogy to other known email addresses from the same institution. We then sent out the emails in the allocated form. This was followed up by one reminder. Instead of then switching to another contact method, such as telephone, we decided to contact an alternative author instead, again with a maximum of 2 emails. Overall, we limited our efforts to a time period of 8 weeks. The primary outcome investigated was the response rate. Secondary outcomes were the data completeness rate and reviewer time invested in author contact. We analyzed data using odds ratios for response and data completeness rates, and mean difference for the time outcome, each with 95% confidence intervals. In addition, the data completeness rate was stratified into clarification of methods and requests for missing data. The request in the email group looked like this. A personal greeting is followed by the description of our systematic review, including the funding source and a link to the Prospero records. All questions are study-specific, and the list was often not as long as this. We finished by providing our contact details and an ORCID to allow interested authors to find out more about who is contacting them. The request in the attachment group was a much shorter email with the same structure. We used 1 or 2 attachments, one for clarification of methods, the other to request additional data. After randomization, the groups were reasonably balanced in terms of characteristics of the corresponding author and characteristics of included studies. Because we did observe a slight imbalance in publication dates, which, as I said before, can influence response rates, we later took a closer look at what effect this may have had on the results as a post-hoc analysis. We started out by locating authors and found that around 80% had reported their email addresses in the publications. Out of these, 17% were no longer valid, so that we needed to invest extra effort in identifying addresses for 1 in 3 authors. This was quite successful, since there was only 1 author for whom no valid email address could be retrieved. However, we still included this author in the statistical analysis. Our primary outcome, the response rate, was high overall, and we found that each step in our process yielded additional responses, starting from the first email to the corresponding author down to the reminder sent to an alternative author. 2 authors in the email group and 7 in the attachment group did not respond, so that we ended up with an odds ratio of 4.5 in favor of email. Looking at the confidence interval, this includes both that email is substantially better and the possibility of little or no effect. The data completeness rate was not as good and gave a moderate 46% overall. Again, each step involved in author contact yielded additional data. The odds ratio for data completeness was 2.2 and so does not give support to our hypothesis that data requests are more likely to be overlooked when presented in an email. Again, the confidence interval includes the possibility of no effect. When we stratified these results by the type of information requested, we found, as others have before, that authors more often provide clarification of methods than missing data. For clarification of methods, we saw that email requests were better than attachments with an odds ratio of 3.2, but this difference disappeared after controlling for the baseline imbalance in the publication year that I mentioned earlier on. For missing data, the completeness rate was low, and we found no evidence for a difference between the groups. Finally, we found that the reviewer time invested into author correspondence was lower by almost 12 minutes per author in the email than in the attachment group. When breaking this down by the individual steps involved, we found that the difference was almost exclusively due to the time needed in preparing attachments. In a few instances, we also translated our emails and attachments for authors from Germany who may have wondered why they are contacted in English by a fellow German person. This also added a little to the difference. This study was limited in several ways. First, the context was a systematic review of studies with administrative or registry data, so the results may not be fully applicable to other contexts. Second, the sample size was limited by the number of studies eligible for our review, and the study may have been underpowered to detect meaningful differences in the rate outcomes. Third, we did not differentiate between missing data available to the original study authors but not reported, and data that were never collected. Fourth, the reviewer responsible for author contact also collected data and was not blinded. Fifth, there may have been some carryover between the interventions after the initial contact was established. We occasionally clarified our request by sending a table within a follow-up email, and authors in the attachment group sometimes answered within the email text. Finally, we did not measure the time taken to extract the data provided by authors. In conclusion, high response rates can be achieved with email correspondence. Locating authors proved to be somewhat less challenging than expected. In combination with previous evidence, we can be reasonably confident that email is presently the method of choice to contact study authors. What this study adds is that designing and pre-filling data request forms consumed more resources but did not increase the number of responses or lead to the receipt of additional data. According to the authors' comments we received, the main obstacles to making study data available were issues with data archiving, lack of permission to share raw data, or the fact that access to administrative data is often limited in time and scope, so that data cannot be retrieved later on. There may be a big difference here to clinical trials. In case of conflicting results between published data and those subsequently provided by authors, it remains unclear which source to trust. This is totally unresolved and may be an interesting avenue for future research. With this, I would like to conclude my presentation and look forward to your questions.